Good day, everyone. Welcome back to the session. And this is our second session, of course, for the day. And we are now going to focus on the international quality infrastructure. We have 5 talks. And after that, we again have a discussion session of about 25 minutes. And if I look at the talks that we're going to have now, I think many of the questions that you had this morning will actually be answered in this session. Let me introduce the speakers to you quickly. The first talk is going to be on quantities and units in e-health, and that is from Dr. Leslie Penrose. And you already saw his remark this morning, and thank you, Leslie, for speaking to us. And let me just tell you quickly about him. He's adjunct Professor Leslie Penrose. He has a BSc in physics and a PhD in atomic physics from the University of Reading, England. And between 1985 and 2012, he was R&D director at the Measurement Technology Division of the Swedish National Metrology Institute. And from 2006 to 8, he was adjunct professor at Uppsala University. He plays a leading role nationally and internationally, being chair of IUPAP Sunamku 2005 to 8 and Euromed 2009 to 12. And he has been chair of ISO TC12 quantities and units 2012 to 21. He develops new quality assured measurement methods in which humans are the main actors. Then after that, we're going to have a talk on DT impact scenarios on QI, and that is from David Hanlon. And so let me tell you something about him quickly. In his current role as secretary of the IEC Conformity Assessment Board based in Geneva, Switzerland, David liaises with many international organizations and presents at international events in various topics. David holds a bachelor degree in electrical engineering from the University of New South Wales in Sydney, Australia, and an executive MBA in management of technology from Lausanne, Switzerland. Prior to joining the IEC in 2011, David's 30 years career spanned diverse professional experience in technical, commercial, and management areas across 3 continents, mainly in international SMEs focused on industrial manufacturing. After that, we're going to hear from the director of the BIPM, Dr. Martin Milton, and he's going to speak to us on comparable measurement for a digital world. So Martin received a MA in physics from Oxford University in 1981 and a PhD in laser physics from Southampton University in 1990, followed by an MBA from the London Business School in 1991. He became director of the BIPM on 1 January 2013, and before his move to the BIPM, Martin spent 31 years at the NPL, the National Physical Laboratory of the UK, where he was a fellow in the Analytical Science Division. Dr. Milton has published more than 90 papers in peer-reviewed journals and has received several awards, including most recently the Finkelstein Medal of the Institute of Measurement and Control for notable contributions to measurement internationally. After that, we're going to hear again, and I say again because he gave us a presentation yesterday, Dr. Roman Swartz, of course, the president of the OI of the CIML, and he's going to talk to us about digital transformation of legal metrology processes. And I know for AfriMet and COOMET, that is also extremely important, I believe for Euromed, of course, as well. But we're looking forward to that. Now, Dr. Swartz is, of course, the president of the CIML, as I said, since 2017. He's a physicist. He was the vice president of PTB in Germany from 2014 to 2002. He's now retired from PTB, but he still works at PTB. Like most metrologists, we don't retire, we die eventually. So then after that, we're going to hear from speakers for basically the digital transformation for accreditation. And the speaker there is Etty Feller, that you already also met. And Etty's professional background is biochemistry and business administration with a major in management. She joined the Israel Laboratory Accreditation Authority in 2000, where she was nominated CEO in 2011. She has over 20 years of experience in the field of accreditation and assessment, and since 2019, she is the chair of ILAC. Her mission is to promote accreditation by qualified and competent organizations in a harmonized way for the benefit of the world. Participants, with that, we're going to start the first presentation. Enjoy the session with us. Thank you.
Welcome everyone to this presentation about quantities and units in eHealth. So, Mike, perhaps you'd like to give a little bit of background about the work we've been doing, the task force, and how we've interacted with various organizations. Is that okay?
Yes, that would be great. Thank you, Leslie. So we created a task force because we saw there were a number of standards development organizations that were involved in similar activities. We have, of course, TC12, who Leslie just introduced himself, and then there was a R group, and we found that there was no acceptable standard for units, quantities and units in healthcare. As broad an industry as that was, we wanted to figure out a way to identify a standard way of identifying quantities and units. So we brought together the two work groups, TC12, which is, I kind of think of them as horizontal, if you will. They're involved in quantities and units across all domains. And our group, which is TC215, is strictly the vertical domain of health informatics. And as I mentioned briefly, you know, if we want reusability, when you collect data for one purpose and you want to reuse it for another purpose, you have to be very sure that people that are using that data understand what they're looking at. And of course, the quantities and units that are being used to describe that data are of utmost importance. And we'll get into it a little bit in this presentation, but if we don't have the same quantities and units, it leads to very unpredictable, and in the healthcare domain, even dangerous situation. So we formed a task force where we got together and we surveyed for the use of quantities and units in healthcare, and we looked at a number of different areas and put together a questionnaire. We had a work group.
You can see they're quite diverse. The United Nations is on board, an organization called SNOMED, initiative called EUCOM. We'd like to share with you some of the experiences interacting with them.
And then this group was kind of the drafting committee, if you will. They were responsible for most of the activity that we did.
If you would like a copy of this survey report, it is available, and we're encouraging input,
Yes.
feedback to it.
Mm-hmm. As I made inference to just a few minutes ago, quantities and units are essential for interoperability and safety throughout healthcare. One of the big examples we came up with, and it's a very unique, an area that's unique to healthcare, is in medications. So, you know, if everybody's not using the same quantities and units to describe something, then we're not going to be able to have the interoperability, the data sharing, the data reuse that we're trying to do. And
it says here that this has become acute as information and communication technologies are successfully deployed in eHealth. There's a real need to review those standards that are out there. And presumably this past year, Mike, I can imagine with the pandemic that this has really taken off. Isn't that so?
It has.
Yeah.
And again, you know, being able to share, one of the examples we talk about later is being able to report adverse events. Well, if everybody is not using if everybody's using different standards, what is it you're reporting? So you can't aggregate the data. You can't bring the data together. It's my apples and oranges
Right.
notion. So yes, we found that to be extremely important. And
so, yeah.
go ahead.
And our two technical committees have very similar missions, so to say. So if we look at your TC215, Mike,
Yes,
your remit.
Yeah, our standardization is a field of health informatics for the coherent and consistent interchange and use of health-related data, and the knowledge to support to enable all aspects of the health system. So
Right.
we're all about using the data, and I think about interoperability, and to this group as computability. The idea is that the data that you're dealing with can be used computationally, and you can perform operations on it. And that's very important. And then that led us to work with Leslie's group with TC12. And why don't you mention your scope?
Right. So our starting point is, from our point of view, so ISO TC12 quantity units, the horizontal aspect that Mike refers to. Our main product in TC12 is a series of standards called ISO 80000. An example, Mike, of the standards that your technical committee, 215, is producing. You indeed have a standard, for example, ISO 11240, addressing units of measurement.
Diagram will show. But with IDMP, there was no, in the entire world of healthcare, the manufacturers were using their own names to describe the drugs. So we brought together in TC215, we had 9 regulatory agencies from all over the world, and TC215 has 63 countries involved. So we came up with a standard that would uniquely identify medicinal products, so that we were all calling it by the same name. So how do you compare medicinal products? How do you compare adverse events when we're all calling it different things?
Right.
So we found this to be very core and very fundamental to our needs. And part of that was the units of measure. And
right.
we created that document that Leslie already mentioned.
So let's take an example from the United Nations, from these international trade examples. On the right-hand side, you can see a standardized packing instruction that the exporter would actually fill in before sending his goods internationally. So I've taken one example, which is a regular physical measurement in space and time of the quantity plane angle. The United Nations then has decided that the common code for that particular quantity is C81. So that's one example of how to produce a code for a unit of measure. In packaging, in this kind of trade, it's not only physical quantities. I've chosen 2 other quantities which perhaps are more relevant to health informatics. One might need to communicate the number of treatments that have been administered. So there's a United Nations code U1 to specify a unit of count concerning the number of treatments. Similarly, there's a code U2, which is a unit of count when counting tablets of medicine. So you can see it's quite a broad area. SNOMED was another organization, a stake organization, and Mike, I think you've worked together with SNOMED quite a bit. Perhaps
yes, we have. So, and this is an interesting example, if you will, but of what the difference is. The SNOMED is a comprehensive terminology, and it's used throughout the world and throughout healthcare for clinical content. So what it enables consistent representation of the content that's used in medical records, and it's mapped into other standards, and it's used in more than 80 countries. What's interesting about SNOMED is that these concepts are related to one another. So in order to come up, the CT is clinical terminology. So the SNOMED is an evolving product that's always being improved upon by the SNOMED group and the SNOMED community. So what they're doing is they're maintaining those relationships, because healthcare is so dynamic and it's always changing.
I was on the website of SNOMED, and I found a case study that they had about electronic health records. So
exactly. Okay.
So this is if I understand it correctly, Mike, it's a kind of standardized way of making clinical notes.
Exactly. And describing all of healthcare terminology in the world of healthcare. And of course, an important part of that is having quantities and units that are consistent and being used in the same way.
Right.
And that wasn't covered until we uncovered it.
Okay, great. So I thought I'd just give you some examples of the specific challenges associated with quantities and unit standardization in health informatics. With this app on the smartphone, say we have a patient who we want to determine his body mass index. So it's a regular physical measurement. We measure the height of the person and the weight of the person, and then we can calculate the BMI index. Now, that measurement can then be coded using the EUCOM coding, and you can see in the example an extract of that particular measurement, where, for example, the code for BMI unit is kilogram per meter square. I mentioned usability, so how does that come in? Let's take an example which could be a very topical example, where we have a mother at home with a sick daughter. She doesn't want to go to visit the GP, her physician, so she has an interaction over the internet with the physician. But usability is really essential in this situation, because if the system is not usable, there really is a risk that there'll be a missing communication between the patient and the doctor. So everything from dissatisfaction to real risks for health if we don't transmit measurement information about health in a reliable way. So if we look at this, perhaps Mike, you can help me out. If we go back to the work program of your technical committee.
Yeah. So, and this is the core of our work, if you will, is that, we are able to transmit information, communicate it, get it from place to place. But if it's not understood by the people that received it, as Leslie was just describing with his example, it's not of much value. It's not particularly reusable. We focus on an important aspect of this is semantic interoperability, that the quantity, values, and units of measurement are commonly understood in terms of the metrological concepts, the information structures for the data exchange, and most importantly, that we're using controlled vocabularies, that when we describe something in one domain, it's understood in another domain. And the vocabularies in the data sets are structured and defined and maintained. And maintaining in healthcare is very important and very difficult because it needs to be kept up to date. And as we're seeing during this pandemic, the knowledge and the experience is changing all of the time.
Sure.
So we have to be able to take care of that as well.
Okay, so I get we should be rounding off here, but before we do that, just I can just match what Mike said for his technical committee with the ambitions of our technical committee 12 quantities and units. So we're interested in setting up a harmonized system of concepts for quantity. So we can present in a harmonized way quantities, units, and symbols and their relations. And thanks to the translatability of those harmonized ways of presenting quantities and their relations, then we're able to promote better interoperability, improved information exchange, more reliable trading, safety of processes and products of all kinds. And obviously there's a big overlap between our horizontal mission and the vertical mission of Mike's TC215. So time to round off, Mike. So we were very happy to be invited by the BIPM workshop to give this presentation of our work specifically in the area of health informatics, quantities and units. and it seems to match very well the ambitions of the task group at the CIPM. Obviously, we see there's an accepted importance of this field of presenting measurements, units of measurement for both print and also in the context of semantic interoperability. We're suggesting a project which would map the SI system to the EUCOM platform. And we need to check how complete EUCOM is, what elements of the SI might be missing for the health informatics area, and do an initial risk assessment of those gaps. And then we have a couple of actions addressing maintenance. So we need to create, we don't have at present, I think it's true to say, Mike, we don't have a maintenance processor yet.
That's what we're going to do.
Right. And we need also to create a maintenance authority, someone of experts who can check to see that we're on the right route. The more short term, as I said, you're welcome to have a copy of the report of our task force, and we welcome feedback from you. In particular, we are discussing with the organisation of the BIPN workshop to hold a follow-up webinar, perhaps in a month's time or so, where we could have up to perhaps 2 hours to have an open debate and discussion about this topic of quantities and units in e-health. So that's about as much as I had to say. Mike, would you like to round off as well?
Well, no, I thank you for the opportunity to present to this group, and we are looking for feedback and input, and we feel like we've made a big step forward, and the best way to progress that is to coordinate with the other groups that are out there and the liaison as we've been in the past and going forward in the future. So thank you very much.
Thank you very much.
Good day to you all. My name is David Hanlon, and I am the Secretary of the IEC Conformity Assessment Board. My presentation is titled Digital Transformation Impact Scenarios on Quality Infrastructure. I hope you find it interesting and thought-provoking. The first thing we need to address for this topic is what is quality infrastructure and what is its purpose. The International Network of Quality Infrastructure, or INETQI, defines quality infrastructure as indicated on the screen. The purpose of a national quality infrastructure is to achieve a certain number of specific national goals. Those goals may include safety for citizens, energy performance, protection of the environment, protection of critical infrastructure, fair trade, and so on. Other goals are often economic, for example, to improve domestic manufacturing quality and facilitate exports. The entire national quality infrastructure, or QI, flows down from these goals. This is the top level of any quality infrastructure. To achieve these national goals, a national policy framework and organization needs to be established, which is ideally risk-based. The national goals need to be prioritized to ensure the best use of the available national resources. The policy framework will put in place mechanisms to encourage good behavior that leads towards the goals, and will put in place mechanisms to penalize behavior that leads away from the national goals. For example, incentive programs and regulations. The persuasive and dissuasive mechanisms will be based on requirements to be achieved. Those requirements will most often be expressed in standards. So the national quality infrastructure will need the capability to either develop its own standards, or will need the capability to be able to select standards from elsewhere, such as international standards. Since the requirements in standards will usually involve some form of measurable limits, Having an appropriate national metrological capability is a key element. The next critical element is the national quality infrastructure, is the capacity to do the checking of products, goods, and services against the requirements in the standards. This is the capacity to assess conformity to the requirements. This is conformity assessment. The national policy for conformity assessment may include pre-market conformity assessment and post-market conformity assessment. The pre-market policies may integrate first-party CA, where suppliers declare conformity to the standards. This is typically used for low-risk products, goods, and services. As the risk of products, goods, or services increase, this is where third-party CA, such as certification, may be required as a policy mechanism. Within the third-party CA policy mechanism, there will be testing laboratories, inspection bodies, auditing bodies, and certification bodies that will check the products, goods, and services against the national requirements. These are the checkers. However, to ensure that the checkers are competent, national accreditation will often be used to check the checkers. The same is true for the equipment used to do measurements. The measurement equipment needs to be calibrated, and a system of checking that the calibration is performed correctly is also critical. The national policy will also often use international global CA schemes as part of the pre-market third-party CA strategy. This is a good strategy because international global CA schemes, such as those operated by IEC, are highly reputable and free of cost for the national QI. So it is a good use of national resources. The national policy will also often have a post-market strategy using third-party CA service providers to check products, goods, and services that are already on the national market. So from a national goals perspective, the national goals drive the national QI strategy. Then to implement the national QI strategy requires a national QI implementation, which achieves the national QI goals, thus closing the circle. Within the national QI implementation, there are three key elements of standards, metrology, and conformity assessment, and an ancillary element of ensuring that the third-party conformity assessment is competent. From a manufacturer's perspective, national quality infrastructure is all about how they can qualify their products for the national market. Market access is their key focus. They must design their products according to the national requirements, which are usually given in national standards, which are often international standards that have been adopted nationally. They must ensure themselves that their products are conformant with the standards, and they therefore do their own first-party conformity assessment. Then, before entering the market, and in fact to achieve market access, their products may also have to be certified using third-party conformity assessment. Once on the market, their products may also be checked again as part of market surveillance activities of the national quality infrastructure implementation. Now we need to address what we understand digital transformation to mean. There are a number of different descriptions or definitions that can be found on the web. Here is one from IEC Strategic Group 12. Digital transformation is all about data as a driver for future growth. Data is one of the most significant transformative factors, creating a means of increasing transparency as a source of innovation and providing the ability to understand, optimize, and personalize. The ability to harness a wide range of large, constantly evolving, and highly personalized data sets is a strong driver for productivity and supports the creation of new high-value services. Digital transformation is all about being increasingly connected. Access to communication has fundamentally transformed economies worldwide, impacted almost every aspect of society, and created enormous value. Future AAL, or active assisted living systems for the elderly, will use home devices and wearables to monitor and communicate health and activity data to an AAL service provider. The AAL service provider will receive data and transform it into information, which will be communicated to health services such as a doctor or hospital, which may then prescribe medications and thus communicate with a pharmacy. And of course, information may be communicated to family members and so on. External service providers will also ensure the correct functioning of the remote devices used by the elderly, provide remote updates and patch management, and so on. Digital transformation is all about increasing complexity. The complexity of systems is driven by the demands to improve efficiency and effectiveness, to drive productivity, and to adapt to changing consumer demands. Multi-directional energy flow from prosumers contributing to smart grids supports the use of renewable energy sources in national grids and supports important future capabilities such as meaningful demand-side energy management. But it takes the traditional unidirectional network model into a complex new direction. This creates significant new technical challenges, the need for data interchange between multiple stakeholders, and the need to assure correct operation in a wide range of new situations. Digital transformation is all about high-speed automated decisions. In the example of networked and autonomous vehicles, humans will relinquish decision-making and control to smart networked systems that are in constant communication with other vehicles around them, that never get distracted by others in the vehicle, or by the radio, or by a mobile phone, and so on, that never get tired or sleepy, and that can take much faster coordinated decisions than is possible by humans. So now that we have a good understanding of what quality infrastructure is and some idea of the potential impacts of digital transformation, we can begin to investigate what effects digital transformation may bring to quality infrastructure. Admittedly, this is somewhat an activity of gazing into a crystal ball. As we've seen, the three main elements of quality infrastructure implementation are standards, metrology, and conformity assessment. So we will primarily look at these three elements. For standards, the effect of digital transformation has already been ongoing for some time. Some 25 years ago, standards only existed in paper form and were delivered in paper envelopes by physical postal services. Then came digital paper in the form of PDF files, which were sent on CDs in paper envelopes. Then came the internet, and PDFs were sent by email or downloaded from appropriate websites. Today, standards are available directly on handheld devices, and tomorrow, machines will read standards directly themselves. In the past, IEC standards were available in English, French, and Russian. Today, they are available in English. Soon, they will be available in XML and in other machine-readable languages. In the past, only entire paper standards could be obtained. Then entire standards in electronic paper form, meaning in PDF format. What's coming is the possibility to obtain selected parts of standards, a sort of do-it-yourself standard. Then there will be machine-readable standards that may read micro parts of standards in microseconds with real-time access. The way standards are developed is also changing. In the past, it was primarily people together in rooms discussing and writing standards. Certainly in the last 12 months, this has been completely replaced by web-based meetings. Then, with the advent of machine-readable standards, could the future, at least for some standards, be machines writing standards? And similarly, while most customers for standards is and has been people in companies developing products and services, could future customers be machines developing products and services? With machine-readable standards, will machines develop conformant products and services autonomously? Is the future, therefore, machines developing machines? All of this also has an effect on the business model for standards, which began with a pay-per-standard model. This has been supplemented by a pay-per-part of standard and a pay-per-view. Pay-per-click will follow, and possibly pay-per-microsecond in machine-to-machine exchanges. All of these changes and possible future changes to standards are not straight-line trends, but will branch out and run as parallel options and facilities. We can expect similar effects on conformity assessment. As an example, just in the last year, the CA industry has adapted to accept surveillance assessments by webcam. But taking the example of traditional product conformity assessment, products are developed and manufactured by humans and machines together. The product is tested by a human in a lab. The test lab is assessed by humans for capability, competency, processes, calibration, and so on. Test reports and certificates are issued in an online database and often as a paper copy. And now, looking into the crystal ball, in the future, the product is tested in a laboratory by a CA machine that reads the requirements in the standard. The CA machine is assessed for capability, calibration, and so on. The CA machine records machine-readable test data directly into an online database. A test report or certificate for humans may or may not be created. Scenario 3 is the same as scenario 2, except that now the products are manufactured autonomously by manufacturing machines that are reading standards. Also, the CA machine can be located anywhere and not necessarily in a laboratory. As long as the CA machine is qualified, it can be anywhere. In scenario 4, we have manufacturing machines that also have the CA machine's functions integrated into them. This combined manufacturing CA machine reads standards, manufactures products, and performs conformity assessment. This is possible so long as the qualification and calibration of all the functions are appropriate. In this way, every product coming off the product line is intrinsically conformant with the standard. In scenario 5, we have machines and systems that are self-learning. They are artificial intelligence entities that are constantly changing and improving. Their rate of change and improvement is much too fast for humans to assess, so other AI entities do continuous assessment. If such scenarios do one day become reality, this means that future manufacturing machines and CA machines and combined manufacturing and CA machines will be able to self-calibrate and maintain metrological records. A current influence of the digital transformation on metrology is the move towards the digital upgrade of QI for legal metrology, the use of digital calibration certificates, and certainly the metrology cloud. Again, one of the important effects of digital transformation is the use and power of data. Of course, for many, the idea of self-calibrating machines may seem far-fetched, but the seeds have already been sown. By no longer relying on metrological artifacts, and with the move to defining all measurement units in terms of fundamental constants of nature. Although today a laboratory is needed to create the conditions for an appropriate calibration, for some units, who can predict what the situation will be in 50 years? As a final comment, there are at least 3 layers for consideration when considering the potential impact of digital transformation. These are technical, political, and ethical. There are many things that are technically possible, but that can be very disruptive and that require political will to endorse or to oppose. And the question should always be asked whether such disruption is ethical and productive. There are those who see digital transformation as dehumanizing technology, where humans are removed from most communications, where humans relinquish decision-making and control in ever-increasing situations, and where artificial intelligence will come to dominate as a new species on planet Earth. And there are those who see digital transformation as putting people first, as leveling the playing field, and enabling equal participation, providing high-quality, value-adding services and empowerment. Every new technology is a double-edged sword with the potential to do good or harm. Thank you for your attention.
I'm Martin Milton. I'm the director of the BIPM, the International Bureau of Weights and Measures, and I'd like to talk to you about comparable measurements for a digital world, and in particular, the work that's going on in the BIPM laboratories and with the BIPM coordination services to support the digitization of metrology. I start by reminding everybody about the SI. This is the agreed basis for everything that we do in measurements. Every measurement that we express can be expressed in terms of the agreed international system, the SI. But the point for us today is that the SI has been a dynamic, a moving system that has developed in response to needs for new applications or when new technologies become available. Indeed, most recently, in 2018, the General Conference agreed the revolutionary new definitions for 4 of the base units based on references to fundamental constants. In parallel with the development of the SI, the work within the BIPM work program, within the BIPM laboratories, has also developed. We took on board the need for measurements of ionizing radiation, for computing the world timescale, to become involved in chemical measurements, to become involved in capacity building. And perhaps at the General Conference in 2022, there will be further discussions about how we can become involved in supporting the digitization of world metrology. So how can the work of the BIPM laboratories and the BIPM databases support the development of new digital NMIs? So we're here in this workshop discussing the initiative by the CIPM to provide and to work towards a digital SI framework. This has been pioneered by a task group within the SI who are aiming to enable SI-based digital communication in industry, to support the digital science and open science paradigms, and to get metrological services ready in the long term for artificial intelligence. At the center of this digital transformation activity, these digital transformation objectives, is the goal of making documents and data within our SI measurement system fair, findable, accessible, interoperable, reusable. Now, when we dig a little into what this FAIR means, we can look at the first two, the findable, accessible, in terms of being the motivation to provide data in a way that is automatically readable by computers, that it should be machine readable. The second two, the I and the R, the interoperable and the reusable, these move us towards providing data that should be not only machine readable, but also machine actionable. What I'm going to talk about now is some of the projects that we have in place that we've already started and beginning to plan to make available data from the BIPM laboratories and data from our coordination services and from the SI brochure machine readable. Let me start by coming to the key comparison database. The key comparison database is, I think, the largest resource of data that we have, that we make available as part of our activities. It has more than 1,600 key comparisons in there and more than 25,000 calibration and measurement capabilities. And indeed, this is data that belongs to, that is shared, that is developed by the organizations that participate in the CIPM MRA. And that's at present, there are now more than 260 institutes doing that. Last October, we started our first project to provide machine readable access to the key comparison database. So what does that mean? Well, since its foundation, the key comparison database has been a website. We updated it over the last couple of years to the KCDB2 format, as we call it, which enables the website not only to present the data, but also to be controlling the workflows within the regions and within the technical committees by which the data is approved and entered into the KCDB. But now we're starting to look at machine readable access to this data, and this takes us all to a new level. So what this means is that a client computer can send an inquiry to the so-called API, the Application Programming Interface, and receive as a response from the KCDB client a response including information in an agreed format about one or even all of the CMCs available. This information is simply the information that is already available through the web interface. There's no extra information, there's no issue of confidentiality here. But the key thing is it's made available in a way that a machine, a computer, can interrogate the key comparison database and receive back the data in a format that it itself can work on. The second digital transformation project that we initiated last October with approval from the CIPM was the development for the first time of a version of the SI brochure in XML format. Of course, recent editions of the SI brochure have been disseminated in PDF format. That's an electronic format, if you like. But that is a human readable format rather than specifically a machine readable format. So we've started the work to develop a version of the 9th edition, exactly the same as the current one, but in the XML format. This XML version can be converted into different formats, such as HTML or to PDF again, by middleware that can be programmed to exactly replicate the data in the SI brochure into different formats. In a next step, we will be putting in place unique identifiers, that, such as digital object identifiers, the DOI, to key information within the SI brochure. So, for example, the definitions of each of the base units or the definitions of the derived units could be identified with a DOI, a digital object identifier, so that when authors are writing about the SI units, they can provide a specific reference to an address that has at it the correct definition, the correct reference definition of the relevant unit. So this takes the SI brochure to a new level in terms of being a digital reference document that is both human and machine readable. But the benefits go further than that. The SI brochure, of course, has within it the 7 mise en pratique for the base units. These mise en pratique have within them a significant amount of very important data that's been approved by the consultative committees and by the CIPM as being the basis for the realization of the units. Let me give an example of how this data could be provided in a machine readable form to provide new opportunities for NMIs to provide a digital traceability. In the case of this example I've got here, we're talking about a digital traceability to the meter. So the traceability to the meter on one side, of course, is based on the definition agreed by the General Conference, by the CIPM, and that you see printed in the PDF version of the SI brochure. But in more detail, to access the exact definition of the meter, it's necessary to access the mise en pratique and the long table in there of the agreed wavelengths with their agreed uncertainties, and actually similarly for the frequencies and the frequency uncertainties that have been agreed by the CCL and the CCTF. This is all part of the SI brochure in principle. So if an application programming interface can be put in place, and this is something we're starting to consider and that I think the CCL will consider when they meet later this year. If an API can be put in place that can access this data, then calibration systems like the 3 indicated in this diagram, each containing lasers operating at different wavelengths. Those calibration systems can directly access the agreed, updated reference wavelength information every time they're used or every time they're rebooted. So in this way, the dissemination of length measurements on the agreed wavelengths agreed by the CCL can make direct reference to the values for those wavelengths and indeed the heritage of those values when they were first agreed, indeed if they superseded previous values. The latest values can be put in place and implemented in calibration reference laser systems anytime through digital access through the API. So that's something that will be discussed by the CCL later this year. So I've talked there about 2 digital transformation projects, both of which are now at the beta testing stage, and we expect to launch in full shortly after this workshop. But our plans go further than that. Probably another one of the very large repositories of data that we hold is in the BIPM Time Department database. The BIPM Time Department, of course, is responsible for the monthly and weekly computation of Universal Coordinated Time, UTC, and we disseminate that through the publication on a monthly basis of Circular T and on a weekly basis of Rapid UTC. That computation is based on a huge amount of data from the network of atomic clocks and from all the information on the global navigation satellite systems and the information from the accuracy and performance of the time transfer links. All of that data is within the BIPM Time Department and is placed within the Time Department database. That database can be accessed at present through an FTP server, which many of the UTC labs use to access the specific information. There's also a lot of information in there that's available through the web interface. But we've started work now towards putting in place an automatic interface, an API interface, to enable access to that data. This API interface, as we develop its scope, has the potential to open opportunities for a number of exciting new uses of UTC time, and also a potential for a number of new services amongst NMIs. So for example, the automatic access to UTC can enable automatic monitoring of UTC-K, that's the timescale in place in each of the UTC labs. It could enable that information to be displayed in real time on NMI websites. It can enable the automatic steering of UTC to respond to the latest computation of UTC itself. Realizations of UTCK can be steered automatically by reference in real time to the most recent published values in Circular T and of rapid UTC. Additionally, it can be used by GNSS operators, and we know there's one published example of this, who are able to access the computed values of UTC in real time through an interface in order to monitor the performance of the satellite system. These are just 3 examples, but I believe in discussion with our time department that there's going to be some interesting discussions at the CCTF when it meets shortly after this workshop about the scope for more digital access to the time data held within the BIPM time department. It's not only length and time where our laboratories have data that can benefit and can lead to new applications if it's made available in new ways. Another example is our plans to put together a global database system for carbon dioxide measurements. At present, of course, we carry out a key comparison, BIPM QMK5, which provides the reference, or the basis for the reference values for measurements of carbon dioxide in the atmosphere at the ambient levels, and underpins the performance of NMI standards. But behind that data is a lot of data in our laboratories about how the key comparison reference value was developed, because in this case it's developed by an independent absolute method. That data can usefully be put into a database system, and automatic access can be provided so that users of this system can have greater access and be provided with greater transparency as to what is the basis for the greenhouse gas measurement scale that's disseminated by the NMIs. So I've talked about a number of projects that are underway. I've talked about the key comparison database automatic access project. We've just launched another one for the JCTLM, that's the Joint Committee for Traceability in Laboratory Medicine database, which will be underway later this year. I've talked about the plans for the time department database. In each of these cases, our objective is to provide automated API access to this data so that use cases that provide real-time validation of traceability and the scope of recognition needed for digital calibration certificates can be provided. The other big project for us is the production of the machine-readable version of the SI brochure. I talked a little bit about that. I've not had time in this talk to talk about the work that's going on towards the development of a machine-readable version of the VIM, our international vocabulary for metrology. This work is going on and it's already accessible from our BIPM website. These XML versions can provide the authoritative reference data that defines the SI and how to use it. Beyond these projects, there are other projects that I know we'll be discussing with the CIPM when we next have an opportunity. And perhaps the biggest of those is the ambition to be able to provide findable and accessible data that underpins key comparisons and underpins our publications, perhaps by enhancing the scope and usability of the IMRR, the International Metrology Resource Registry that we already host. So how can we at BIPM support digital NMIs? I think we can do that by supporting open data practices like the FAIR that's been discussed in this meeting, by implementing new digital formats for metrology data and metrology publications, and by providing machine accessible data and reference information. Thank you.
Good morning, good afternoon, whatever fits to your time zone. In my presentation today, I will take up what I briefly introduced already yesterday. So today's talk will be about the digital transformation of legal metrology processes. Let me start with a short explanation of what legal metrology is. Legal metrology is the legal framework set by governments and regulatory bodies of a country or economy to create confidence in official and commercial measurements and transactions. Thus, legal metrology serves to protect the citizen and to ensure fair competition in trade. These goals are achieved through legal and technical regulations, conformity assessment, and regular supervision of measuring instruments by accredited or otherwise authorized bodies. For legal metrology, the digital transformation is a real challenge. I've shown this slide already yesterday, but would like to present it here again in order to explain in more detail the various processes and legal metrology steps during the life cycle of a product. The life cycle of a product, the measuring instrument, begins with the manufacturer, who is responsible for the product design and the production line, where a third party takes care of the conformity assessment steps, comprising type examination and the surveillance of the quality system for the production. These two steps, accompanied by market surveillance activities, guarantee that the products which are placed on the market are in conformity to the approved and certified type. These activities are often designated as pre-market activities. Once the customer has bought the product and has put it into use, he will be responsible for the proper installation and use, and has to take care that a verification body performs the verification and regular re-verification. These activities are designated as post-market activities. In addition, the instrument usually also requires regular maintenance, eventually repair, and also software updates. For the sake of completeness, I would like to mention again that in some countries and regions, market surveillance is also considered as a post-market activity. Looking at the various processes during the life cycle of a product, it becomes obvious that the digital transformation of these processes can only be successful and effective if it is based on the exchange of fair digital data, where the emphasis is on the I, that means the interoperability of digital data and processes. Here I would like to present a more detailed view on how a fully digitalized life cycle of a network instrument could look like in the future. The picture here focuses on the various legal metrology activities, but it can equally be applied to other metrological activities such as calibration. The blue circle shall represent the Internet of Things, where all relevant data are stored in a secure cloud. The box in the middle shall represent the smart measuring instrument and its digital representation. I shall provide a more detailed explanation of the concept of a digital representation on the next slide, but would like to mention here already that it is understood as a representation of the physical instrument which contains not all, but the relevant data of an individual instrument throughout its lifetime. The life cycle starts again with the manufacturer, who is responsible for the production of the measuring instrument, its remote control and remote maintenance, as well as the continuous analysis of incoming data. The smart measuring instrument is marked electronically, for example with a digital plate, which forms part of the data stored in the digital representation. The certification body or other responsible authority takes care of either peer assessment or accreditation of the manufacturer, the supervision of the manufacturer's quality system for the production, the conformity assessment of a new type of measuring instrument, which could be done remotely in the future, where the respective certificate and related test report, etc., can be stored electronically, for example, by a digital certificate of conformity, which is again stored in the digital representation. Provided that a test laboratory has successfully performed a test, maybe even more tests, and issued an electronic or digital test report to be used by the certification body. The Market Surveillance Authority will perform a remote supervision and ensure remotely conformity to type. The initial verification and periodic re-verifications, as well as sampling inspections and other activities of the inspection bodies and verification authorities, will also be done remotely, where an electronic or digital mark is stored in the digital representation of the instrument. We can expect that in the future, certainly after a transition period, all the information in the red boxes, that means the software information stored in the digital representation, will completely replace the traditional way of hardware marking verified instruments. Of course, the customer is responsible for the proper use according to the specifications of the manufacturer and the legal requirements. Last but not least, the accreditation bodies are responsible for the accreditations of the manufacturers and other stakeholders involved, for example, certification body and test laboratories. To be very clear, this is a vision and not yet reality, but many colleagues are working hard to make this vision become reality in the not so distant future. Before I'm going to give some examples of where the digital transformation process has already started, I would like to repeat what I have said yesterday already. The digital transformation of legal methodology processes, and I would add of all methodological processes, can only be successful and effective if it is based on the exchange of fair digital data, where the emphasis is on the I, that means the interoperability of data and processes. As announced already, here are some more details about the concept of a digital representation in metrology processes. For legal metrology purposes, digital representations contain all relevant information that the responsible bodies need to perform the conformity assessment, the verification, market surveillance in a machine-readable way. Digital representations also know the relevant standards and regulations and provide machine-readable information about it. They also contain all relevant information for customers to gain trust and confidence in the products and quality measures. They provide machine-readable interfaces for users and manufacturers to enable smart quality assurance, and combine machine-readable documents and certificates, hence enable automation of digital quality infrastructure processes. Very importantly, they are secured and validated to provide access to information only to eligible parties. The Digital Certificate of Conformity Metrology, the DCOCM, is my first example of where the digital transformation process has already started. It is a project that PTB has recently started in cooperation with the weighing industry. The idea is that the DCOCM forms part of the digital representation of a measuring instrument under legal control, for example, a weighing instrument, where it contains the type evaluation certificates, the certificates of supervised manufacturers' quality systems for the production, and other relevant documents, and provides the legally prescribed information as machine-readable data, for example, digital data plate, digital test report, digital verification mark, etc., to enable stakeholders to perform all legally prescribed actions. This will require a holistic approach to address the needs of all stakeholders involved during the lifecycle of an instrument. All this is intended to be realized using fair digital data based on the SI. The other example of where the digital transformation process has already started is the Metrology Cloud project, also initiated by the PTB. It is kind of a prototype of a European platform for the digital transformation of legal metrology processes. The objective is an easy but secure remote access to the relevant digital data by all players involved, where the players are manufacturers, conformity assessment bodies, verification bodies, and users. Let me use the example of a software update to illustrate how the process is intended to work. In step 1, the manufacturer has developed a software update, which is to be uploaded into the digital representation stored in the secure Metrology Cloud. In step 2, the manufacturer informs the responsible conformity assessment body who evaluates the update. In step 3, the user will be informed about the update and its successful evaluation. If the user accepts the update in whatever way he prefers, the update will be installed in the measuring instrument. Finally, in step 4, the responsible verification body is informed and tasked to re-verify the measuring instrument. After the successful re-verification, a new digital verification mark is stored in the digital representation of the instrument. What is the current status of the Metrology Cloud project? So the Metrology Cloud test network is being set up, where the partners currently are the PTB in Germany, the Czech Metrological Institute in the Czech Republic, and the Sartorius company as industry partner. New partners are welcome. Information is provided under the given link to the Metrology Cloud project. The architecture of the Metrology Cloud has been published, for example, in the April 2020 edition of the OML Bulletin. The digital interface to German verification bodies is currently under construction, and a first real use case with industry has recently started, and future spin-off projects are planned. Finally, let me briefly present how the OML reacts on these exciting developments and how OML contributes to the digital transformation process. Firstly, I'd like to mention the development of internationally harmonized general requirements for software-controlled measuring instruments published in OML document D31. An updated revision has been published 2 years ago, and the responsible project group is already working on the next revision to accommodate current trends in legal metrology, such as machine learning, remote verification, and new operating systems. For example, to enable future remote verifications, the responsible project group currently investigates whether devices' responses using a physical copy or a digital representation are comparable. As another example, the next edition of OML D31 will include aspects of secure access to legally relevant data, protection of transmitted data, and authentication of the parties involved. The OML, in cooperation with partners from member states, also organizes or supports respective workshops. For instance, a workshop on the digital transformation in legal metrology. This workshop was originally planned to be held in Berlin last year, but had to be postponed because of the pandemic. The joint OML PTB WELMEC workshop will now take place as a one-day webinar on the 5th of May this year. It will address current challenges, opportunities and solutions regarding digitalization in legal metrology, and is especially intended to provide a platform for the exchange of new strategies and concepts. For more information or registration, I refer to the given link on the OML website. Finally, I'd like to mention OML's cooperation in the field of digitalization with other international organizations, notably the BIPM. Last year, a new joint task group has been established after approval by the respective international committees, namely the CIPM and the CIML. The major aims of the joint task group are to foster enhanced cooperation between the BIPM and the OML in order to facilitate both organizations in serving the member states better, and to speak with one single voice for metrology. The major strategic objective of the joint task group is to develop and promote a common vision and a common holistic concept of metrology as a key element for the active promotion of the quality infrastructure concept. The action plan includes, for example, the joint promotion and support of the digital transformation of metrology. With this, I want to conclude and summarize my presentation as follows. The digital transformation of legal metrology processes, but I could say of all metrology processes as well, requires a holistic approach and a close cooperation of all stakeholders. The OML supports a digital transformation of metrological processes that fits to the natural life cycle of smart measuring instruments and systems. Data formats for digital representations should be fair, should be based on the SI, and should be complete. That means should include all relevant information that is necessary to perform any kind of metrological activity by the relevant bodies. The OML contributes to the digital transformation process by providing internationally harmonized software requirements, organizing and supporting respective international and regional workshops, and cooperating with other international organizations in the field of quality infrastructure, notably the BIPM, ISO IEC, and ILAC-IRF. With this, I thank you for your attention. If there are any questions, I'm certainly ready to take and answer them in the Q&A session. And thank you.
Hello, everyone. It's a great pleasure and privilege to give you a short presentation on behalf of ILAC. Accreditation, International Quality Infrastructure in Practice. I'm Eti Feller and I'm the ILAC chair. The main topics in the presentation will be the ILAC MRA, how it works, the assessment system, reality, risks, challenges and opportunities, and some publications. The ILAC MRA in summary. ILAC MRA in summary means that 102 ILAC MRA signatories, which are accreditation bodies. We as signatories accredit more than 80,000 accredited laboratory, 12,200 accredited of inspection bodies, 560 accredited proficiency testing providers, and last but not least, 200 accredited reference material producers. All of us are eligible to use the ILAC MRA mark according to an agreement between ILAC and the signatories and CAPS. So how it works? The ILAC MLA MRAs of a region that recognize is eligible to use the ILAC arrangement, the ILAC MRA. Currently, the MRAs of 5 out of 6 regions cooperation bodies, AFRAC, APAC, ARAC, EA, and IAAC are recognized by ILAC. Recognition of a region is achieved after a successful peer evaluation by ILAC every 4 years. Signatories to the regions cooperation bodies are also members of ILAC and entitled to become signatory full members of the ILAC MRA. All of us can use the ILAC mark. ABs, all the ABs as signatories to the ILAC MRA work according to ISO IC 17011-2017. The definition of assessment technique, method used by an accreditation body to perform an assessment. Process undertaken by an accreditation body to determine the competence of conformity assessment body based on standards and or other normative documents and for the defined scope of accreditation. So this is the process that each one of us have to follow and to make sure that we work according to the standard. The updated ISO IC 17011-2017 also defined several assessment techniques. Assessment technique can include, but are not limited to, on-site assessment, the traditional way that all of us around the world are familiar with, remote assessment, which for the last year became more and more preferable by ABs and CAPs, witnessing, documentation review, file review, measurement audit, review of performance in proficiency testing and other inter-laboratory comparison, validation audit, unannounced visit, and interviewing. Some of, if not all of them, can be done remotely, and digitalization is part of our life for the last year in each one of them. In the next couple of slides, I would like to express our views, to share our views about the situation that all of us are part of it and how digitalization affects our life. The next slides will be about reality, risks, challenges, and opportunities. Reality. The reality indicated the need to be prepared for systematic changes because of global issues. We have to address the fourth industrial revolution and to contribute to the society. The accreditation services are changing and have to be more open-minded. The process and information are shared in more secure way, not only via mail. And we have data security issues these days, and data from organization and CAPs from for long-term use. The risks that we face and we have to take into consideration is the changes to the model of the way we work, changes to the model that work, and how it affects the outcome, access to advanced method, remote method, and to make sure that we use an appropriate system, a validated system. Also, changes to the process recognized by the regulators and stakeholders. Remote assessment is a challenge to regulators and some of our stakeholders since they believe only in the traditional way. And last but not least, confidentiality and all what we know as penetration tests and other issues that relate to confidentiality in our digitalization work. So the challenges. The time to implement new technology is very short. In some cases, we had to do it in a couple of weeks or couple of months. We have to make sure that employment skills are adequate. Information load. We have to think or rethink, do the AB need all the information that we have had till now? We have to look again and to make the best use of the data that we get from ABs and to make sure that it's relevant to the use. AI has a potential to evaluate our decision, and some systems already challenge our way of getting to a decision. And the question is whether we are ready that artificial intelligence will be part and will take decision according to our outcome from assessments. And it means that changes to the conformity assessment, the product can be provided differently, and ABs must have the competence assessor, which is a challenge, especially because this issue is new in some countries. In other, we already work remotely and with experts in IT and AI. Depends on the needs of the country, the regulators, and some stakeholders. So, having said all these issues, the reality that we live in, the risks and the challenges, I think that we have to take a look at the opportunities. It will help us to give an effective service to everyone, to our CAPs, to the regulators, to the stakeholders. The decision-making process might be shorter. We have to look in the box or out of the box, and maybe to implement some startup organization work. We have to take a look again on the data that we collect from previous assessment and to work out whether we have to repeat and what we have to repeat, if at all. And to make sure that we at least think and learn and train ourselves in artificial intelligence that might improve analysis of, at least improve analysis of our assessments. ILAC publication for your use, all the guidelines and policy documents, although all of us around the world had a challenging year, some documents were updated. Especially, I want to make sure that everyone in this audience knows about ILAC P10 from last July and ILAC P14 from last September. P10 ILAC policy on metrology traceability of measurement results. P14 ILAC policy for measurement uncertainty and calibration. And please take a look at the transition period. For most of them is 1 year or a little bit more. And the fact sheet, we have a specifying accreditation for COVID-19 testing that was published on August 2020 in order to give our signatories and CAPS, regulators and stakeholders support from accreditation to the current pandemic that we are all affected by. Here is the list of source of further information for your review. We will be happy to get your feedback, and if you need any more information, please don't hesitate to contact us. And with that, I want to thank you, and we'll be happy to answer any questions or anything else that you think that I can answer. Take care and stay healthy. Bye-bye.
Hello everyone again, and thank you very much to our speakers for the presentations. As I said previously, I was sure that they will answer many of the questions that you had this morning. And of course, these excellent presentations did that and also lead us into our final session of the day, and that is a discussion session. Can I just check if Dr. Noah has joined? Thank you very much, Philippe. I've got it. And everyone just bear with me for a moment because I just need to now go through the questions. I will actually start from it looks like the most recent questions, but bear with me if I don't go in sequence that you have put the questions. The first question that I see here is from Mr. Mohammed Helmi, of course, from NIS, and he asked Dr. Milton, the KCDB2 is now perfectly controlling the whole process of the CMCs, from the submission to the approval, and many thanks to the BIPM for this great improvement in that direction. For the KCDB2, CERT's facilities that are important for the metrology community by providing valuable digital data, is there any plan to do considerable improvement during extracting and saving the details? But yeah, Martin, I think in general, just the plans for the KCDB digitalization, please.
Well, thank you for the question, Mohammed. It's certainly something we're working on already. And actually, we are close to launching an application programming interface that will provide this kind of functionality. If you or your colleagues in your NMI or anybody else who's watching would like to be part of our beta testing of the new facilities that we're providing to search the publicly available information about CMCs automatically, then please send me an email and we'd like to get you involved.
Thank you, Martin, Dr. Milton. Thank you very much. Colleagues, the next question that I see here looks like I can't see the full name, unfortunately, on my screen now. And now I think it's Richard. And to Leslie Penrose. To what extent is it desirable to mix the description of quantities, a semantic problem which is difficult, and units, a syntactic problem that is easier? Leslie, I think you can see the question there. I'm not going to read the whole question. It's quite a long one. Are you able to already answer on what I said? Should I read it further for you? Oh, that is fine. Thank you, Philippe.
Sorry, I don't mind my microphone muted. Is it better now?
Yes, thank
Thank
you.
you.
Now
Sorry.
you proceed, Leslie, and then Noah can take the next question. Thank you.
Yeah, so sorry about that, Wynan. Thank you, Richard Brown, for that interesting but technical question. I'll just respond very briefly to that. What comes first, I think, is the concept of quantity, and then the concept of unit. Now, those of you familiar with dimensional analysis will obviously be familiar with doing that analysis in terms of units. But fundamentally, it's not just about units, about relations between quantities. So my brief answer is you want to do the work properly, and you should start with quantities and do your dimensional analysis there. But we should discuss this later on. It's a paragraph, a concept in the 80,000 series, part 1, kind of quantity, that important concept. Thank you, Wyland.
Thank you.
Okay. Next question to Mr. Hanlon. The IEC business model is keeping the standards behind a paywall. Are there plans to release measurable standards of general importance to today's topic to the open access?
So yes, good day to everybody. This is an interesting question. Of course, the ISO and IEC are sister organizations, and they are both based on the same business model of selling standards. And so, of course, there is a move for certain standards to become free of cost, free of charge standards, and both ISO and IEC are together struggling with providing services that allow this to happen and still stay in business, if you like. So there are already certain standards that are available in a certain form, or will be in the future. Of course, this is not all standards, because it's not required of all standards, but certain standards will be available to be seen, not necessarily to be acquired. Now, the question is, of course, concerning machine readable standards. That is yet to be seen, that is yet to be discussed, that is yet to be understood exactly what those needs are, for which standards, and how that may be done in the future. So at this stage, it's a bit of an open question. It is something that will be discussed going forward in these terms. Thank you.
Sorry, thank you very much. Next question from Ms. Nadia Galdoveski. We have, the question is to Dr. Martin Milton. How will the role of NMIs to be changed in the age of quantum metrology?
Well, thank you for the question. It's a question that we've all been thinking about probably since 2018, or particularly since 2018, when the new definitions for the base units were agreed. It's a question that the CIPM are really investigating as part of their strategy. I think the CIPM president told us earlier that the CIPM strategy will be looking forward as far as 2030 and beyond. And one of the key topics it'll be looking at is how will metrology develop, and how will the role of the NMIs develop in this world of quantum measurements. So look out for the CIPM strategy, which is going to be published before the end of the year.
Thank you, Martin, very much. Going to next question from Mustafa. Can't read the rest of the name. Thank you for presentation to Roman. What is the most important task for legal metrology authorities in digital transformation, and what advice would you like to give to legal metrology authorities?
Thank you, Mustafa, for this question. I would like to give a rather general answer. I think the key word is cooperation. we are still at the very beginning of the digital transformation process, which is certainly a big challenge for legal metrology authorities. I'm convinced that we definitely need a follow-on process following this excellent workshop, where we together and jointly look at the next steps. And the most important thing I would like to emphasize is we should cooperate in the region and do not look at national ways to cope with these challenges, but look at the regions, look at the cooperation with others, and the international cooperation.
Thanks, Roman. Next question from Florian, to all actually. The stakeholders in the QI are interconnected within processes which exchange data, which are stored in databases in the individual IT infrastructure of each stakeholder, worldwide and regional. Could this infrastructure not be interconnected, and the processes which benefit the most from digital transformation not be identified? And what could such a process be? It's for all, actually. Would like to interact.
Yeah, is there anyone that wants to have a go? Martin, Milton, perhaps? I don't know if you can say, otherwise I can try to say something about it.
You go ahead, Mr. President.
I'm just searching actually for a full question here on my system, but if I understood it correctly, it is how we can all work together using digital to really try and pull everything together, the regions. Was that correct? I hope so. Like I say, I just missed part of the question here on my system. But yes, I think this workshop is in any case a very good start for exactly what you are asking, and for us to formulate how we can actually use digitalization to do that, to do exactly that. And I think this is an excellent start for all the international organizations that are basically part of the workshop to shape our cooperation better. The CIPM has got the task group now for digitalization. And as you can see from the workshop, we are already working with all the other QIs, the ISOs, the ILACs, OIML, and then CODATA, and all the others. I hope I answered it correctly. Anyone wants to add to that?
If I could just add an element there to your response. The question here is about the QI infrastructure, which is important, but it's important when it delivers value and what is needed to end customers. So I think part of the answer to your question there is the QI infrastructure will need to be very responsive to how customers want to be involved in new digitally transformed services. And perhaps that's something where we should be listening very well and engaging with customers to understand what they want.
Okay, so thank you, Martin. Moving to the next question from Emilio. Talking about metrology continues to be invisible in many areas despite its uniquity and underlying nature in all fields of science and technology. Metrology is a science responsible for ensuring the reliability, accuracy, and uncertainty of measurements data and its correct expressions. Without the necessity first step, the interoperability of the data could lead to, it's a very long question actually, and can lead to, I'm sorry, an expansion of inappropriate data, making it true what George have said before, something not nice. And any data processing we do, no matter how good, might not guarantee a correct decision or conformity assessment. Do you process this as a risk? Do you think this is a risk?
I can perhaps have a first go and then Martin can go after me. Well, you know what the mandate is of from the Meter Convention to the CIPM and PIPM, and that is basically to establish a global measurement system. And for that, of course, we developed the SI and we maintain the SI. We have got the SI brochure, as Dr. Milton explained. So I think the first answer is that we try to make sure, we don't try to, we make sure and work with everyone to do that, to basically have this worldwide agreed measurement system. And then we summarize that in the SI brochure. And as Dr. Milton explained earlier, we are now digitizing the SI brochure to make it machine readable, and that you can actually, if you need a format, you can hopefully get it from there, how you want to express the quantities in a digitized format. So I hope that answers the third part of the question. Yeah, on the data, Martin, do you perhaps want to add to that?
Yeah, thank you for the question, Emilio. I think I'd like to address an answer to the question very much in the context of this workshop on digital transformation. So yes, we know metrology is the foundation from which the chain of value is developed. We know that. And if that foundation isn't right, there is a risk of the wrong output. And I think the question for discussion over these 5 days is, how can digital transformation aid us in avoiding any sort of problems with that in the future? Actually, I gave 1 or 2 examples in my talk where I talked about the vision, for example, in the length community, where a calibration laser system could itself be able to access the most up-to-date reference data regarding traceability to the meter. And that could be done itself. So I give that example again because it's an example of how digital transformation can make sure that the whole traceability chain is using absolutely the right references at the highest level to the SI. So I think as we continue the discussions over these days, we're going to see other examples where digital transformation can greatly act to reduce any of these sort of risks that we saw in the past, where traceability chains were not to the right reference or were to an outdated reference or something like that. I think digital transformation can really help us improve all of these.
Leslie, would you like to add something?
Yes, please.
Okay.
Just to add to what Wijnand and Martin responded to this question from Emilio, I'm encouraged by the session earlier this morning, where we heard from, we say, the stakeholders of the metadata community. We see already that they already have established a metrological part of their ontologies. So Simon Cox mentioned UCOM and QUDT and so forth, their interpretation of metrology. So it's not that they're ignorant of what the NMIs are doing, but they've chosen to develop their own systems to start off with. And I think exactly as Martin is saying, the purpose of this workshop is to bring the metrologists together with those stakeholders so that we harmonize that development going forward.
Okay, thank you, Leslie. Do you would like to add something, David? Okay, go ahead.
Yes, thank you very much. Although this is a metrology question, or at least focused in that direction, and of course I'm representing the IC, which is a standardized international standardization organization and an international conformity assessment organization. I can see a lot of parallels with this question that apply to the standards and conformity assessment side, because they are also relatively invisible and yet ubiquitous. The issues certainly are about, as the question proposes, what happens when the way in which processes are done result in results that are in fact not appropriate or not correct. this idea of garbage in, garbage out. And those sorts of issues apply today and will apply, will have impacts in the future as we move more closely to a digital future. We are already some stages towards that today, but certain safeguards will have to be put in place, which we maybe do not know exactly what they are yet today, but those will be developed, and of course mistakes will be made and they will be corrected. And so this is an ongoing process to ensure that the results are in fact appropriate and of highest quality. That would be my comment.
Thanks a lot, David. This is very encouraging. The next question from Angelique to Dr. Martin Milton. How can the slow process of the development, harmonization, and adoption of concepts and vocabulary such as the version of the Vim adapt with the fast path of digital transformation?
Well, thank you for the question, Angelique. I only had a moment to touch upon this subject in my talk, so thanks for the opportunity for me to say a little bit more about it. 2 or 3 years ago, the committee that developed the Vim were actually the first to provide a true machine-readable access to their product, the first in the standardization community that we work in. That machine-readable system is available from the BIPM website. It's called the Annotated Vim. And that system has all the characteristics that one would associate with a machine-readable system. And indeed, in a small step planned, it will become a fully machine-readable system producing JSON and XML output and so on. So in terms of the technology, if you like, of vocabulary development, I believe the Vim committee are actually in the lead in our community. Regarding the process of agreeing definitions, the definitions themselves, of course, this is a process that is as fast or as slow as the process of developing consensus amongst the member organizations involved. In the case of the Vim, I think the Vim takes great pride in the fact that it represents 8 member organizations of the Joint Committee for the Guides on Metrology, the JCGM. So developing consensus does take time, but as far as the technology of digital transformation is concerned, I think they're in very good shape. Please take a look at our website and take a look at that annotated Vim.
Thanks, Martin. And next question from John Barth to Eti. Is there any program within ILAC to provide a searchable database of accredited laboratory capabilities, perhaps similar to the KCDB?
Thank you for the question. I think that it's a wishful thinking that we will have an international database for all scopes of accreditation. Right now, I can't see it work because even for the calibration lab, we face some issues. And most of the scopes are according to 17011 definition, but still in some countries, there are some additional requirements by the regulators. This is the first thing. So, and the second one is the way that ABs work around the world is different. All of them must publish their scope of accreditation of the ABs. All of them has a search option on the website. But I think that to take all these scopes in all different areas, because KCDB relates to mostly for calibration, but there are a lot of other areas. So I can't see it in the near future. Thank you.
Wynand, please, do you want to say something?
Yes, thank you, Noah. I actually just wanted to add something on this from the AfriMed's perspective. What we plan in AfriMed's, we've got, of course, most of our NMI laboratories are third-party accredited, and they have their scopes of accreditation, and our approval of the quality systems as fit for purpose for the CIPM mutual recognition arrangement are based on third-party accreditation and then basically on the scopes of accreditation. But we only have 5 members or states parties to the Meter Convention and 10 associates of our General Conference. So 15 countries of the 46 in Africa that participates in AfriMed's basically have their calibration and measurement capabilities in the international, the KCDB. So what we plan to do is to develop an AfriMed's database of the capabilities of the NMIs in Africa based on their accreditation or peer-reviewed capabilities. And that will then be a repository of all the scopes of accreditation basically as well. So this is for our African continental free trade area that we are going to develop this with some of our developing partners. Thank you.
Thanks, Wynand. Next question from Thomas. He first thanks for the presentation. Are there already any plans or actions how to handle all CNN-based technology as metrology system, and how to ensure input data quality according to level at model building data quality and consistency? Overall utilization from training to measurement seems to be key. How might continuous learning of the model be incorporated in view of the traceable QI? It is not for certain person. Anyone would like to interact with this question?
Yeah, Dr. Noah, it doesn't look like any of our speakers is volunteering to answer this one. I think it's getting down to the practical level a bit. And I just do a final check if anyone wants to answer. Doesn't look like it. So can we perhaps go to the next question?
Okay. Second question from Mohammed. Although we have different level of things in metrology, primary, secondary, regulation, guidelines, why most of the proposed ideas on digital transformation in metrology are treating everything the same manner? Could not we have different levels or different paths to digitally transform metrology devices or processes?
Oh, maybe I could jump in. This is again a metrology question, not really, and certainly focused at metrology, but I would say the same sort of issue can be focused at the standards and conformity assessment side of things. And again, I think we don't really know what will be needed in the future. We have some ideas today. Certain things are approached in the same ways. As I said in my presentation, it's a little bit crystal ball gazing, trying to answer some of these questions, because we don't really know what will be the most important aspects for certain subjects in the future, what the market will accept, what the market will need, and of course, only time will tell. So at the moment, a lot of what we are trying to propose or looking at is using our imaginations and thinking it through as a sort of a thought experiment to try and understand where things may go in the future. But it's still very much guesswork at this stage.
Yes, I can perhaps just add a bit to this. Look, this is a very good question in sense of what we said yesterday, or a question that we had yesterday between what's the difference in digitalization within the developed countries and the developing countries. And this speaks to that as well. Can I just say that in the metrology world, we actually do have a first tier and a second tier system in a way, where we have the CCs, the consultative committees, the key comparisons, and then at another level, we have the regional metrology organization comparisons and activities. And there it pulls in basically the countries at perhaps a lower level, if I may call it that. And I can really see that what we're going to do in this field from the CIP and BIPM side will definitely happen in the same way. You have the top NMIs or the NMIs that is leading in this field, like the PTBs, the NISTs, the NMIJs, and many others. And then, say, for example, in Africa, we have the countries that will really take on a lot of these as they are developed by the top NMIs. But on the other hand, as you saw from the presentation from OIML, from Roman, there are so many things in digitalization that's very important for our level of operation in Africa, where legal metrology is basically, in a way, the basis of our metrology system. I hope that answers it as well. I don't know if there's anyone else that wants to say a final word to me.
No, thanks. Thanks, Ryan. Moving to the next question from Luke Erard to Eti. Will accredited laboratories able to deliver digital calibration certificate readable by the calibrated instruments in order to perform the correction automatically?
Great question. Thank you very much. I think that in some countries, the answer is yes. In others, no. And the reason, and it's something that was raised earlier today at the same session, it's related in some countries to economy regulation. And what is an official certificate or results of calibration? So we know that in certain countries, all the work is done digitally, and they send the certificate. And in some cases, if it's something that relates to computer, the calibration lab is able to connect to the equipment remotely and to do the calibration. So it's important to understand that we don't work in an isolated island. We work according to the standards, but we have to follow also economy regulation. In some regions that there are also regulations. And in this case, I want to mention two websites that I mentioned yesterday. That you can find there a lot of case studies that will help in this question, especially with regulators. The first one is the public sector. And in this, we have a lot of case studies. Some of them also relate to digitalization of the service, of the accreditation. And the second one is the business benefit. Since not all is NMIs, or most of them are private calibration labs that give services, they are in some cases more mature and more open-minded to give services in a new and digital process. And last thing that I want to mention in this point is that at the end of the day, we also serve our regulators. And it's not only the rules in some economies that are reluctant to introduce changes, but also the regulators fear from changes because of labor acts. And in some cases, they think that if there will be a digitalization of information, maybe they will lose their jobs. I know that it's not related to accreditation, but it affects all of us around the world. Thank you.
I wonder if I could come in there. When we talk about digital transformation, I think the very positive thing about it is opening new opportunities, new services, new value to customers at the end of the traceability chain. And I wonder if I could come back to you, Etty, please, to say, when we have this concept of the digital calibration certificate, it would travel between, or it would link the SI realization through an NMI, through a calibration lab, all the way to the customer, and perhaps with many steps between the NMI and the customer. It seems that the accredited labs play a central role in the central part of this chain. And I wonder if I could come back to you, Etty, and just say, are there any plans in ILAC to start to think about how a digital calibration certificate might work in your community?
Right now, may I?
Yes, of course.
Okay, thank you. Right now, you know, we have ongoing a very active working group that deal with calibration issues. In some areas, as I mentioned previously, we have already implement digitalization and transfer of information. For example, someone gave the example of the wine industry, weight, labeling, color, and so on. So some of it's calibration, and the other ones is chemistry. And they have a QR code with the product that can show you all the information. We have it also in some agricultural products. But the issue is that not all the end users, the stakeholders, are willing to update their systems and to work with this issue. In general, yes, we work on it, but it's not only for the last year, but for a long time now. Around the world, there are a lot of industries that use digitalization part of their basic work.
May I just quickly jump in as well? Yeah.
We have only 1 minute, but please.
Okay, I'll keep it very quick. I think it's inevitable that such systems will come online. It may take time for certain. There will be certain players who are in advance. There will be other players who will be, lagging behind. But it is inevitable that such automated systems will communicating with each other and giving valuable information will occur in the future. Again, whether it's positive or negative to humanity is another question, and that's something that the future people on this planet will have to try and decide. That's my reply.
Thanks a lot, David. Thanks a lot for all of you, dear experts and speakers, for your contributions. And thanks all for all participants who submitted their questions. I hope we could fulfill their answers. Anyway, we collect the questions, and I understand that the committee of this workshop will cover everything later on. Thanks a lot, and I give the floor to Dr. Lou to close this session.
Thank you very much, Dr. Noah, for handling our question session. I think it's excellent, and I think the big thing of this workshop is that we're all connected to each other today. We're talking about these things, and of course, that gives us the basis to also plan better together, as Dr. Moulton also said previously, and all the other speakers. So let me also thank the speakers and our moderator, Philippe, and thank you for behind the scenes doing everything. And please, everyone, don't forget to join us then tomorrow for the second day of basically our RMO workshops. You will have a new chair and a new moderator. And so from Dr. Noah and myself and all the speakers, all the best, and we see you tomorrow. Thank you very much and goodbye.